Hi, welcome to the CoprHD Community Show. You may notice that things look a little bit differently from the rest of the video that comes on after this. This is due to some technical difficulties we had with the audio recording equipment. We do apologize, and so we're recutting this video now. What you'll see later on is a set of interviews with the greater CoprHD community and ecosystem from partners and developers who are contributing to the CoprHD community. One of the things we announced this week is the release of CoprHD 2.4, which for the first time is available in a downloadable software appliance in an OVF format. If you go to coprhd.org/download, you'll find all about it. That's coprhd.org, coprhd.org/download. The other thing we announced this week, and this, in my mind, this is more exciting than the actual release itself, is that we announced new partners, new contributors, new governance, new technical steering committee, new licensing, and new projects. We'll start with the new projects first. The first new project I want to talk about is the OpenStack integration, which right now is focused on Cinder integration, which allows users and developers of OpenStack to choose either the Cinder or CoprHD API when consuming or orchestrating block storage. The other project is a southbound SDK project, which we're rewriting to make storage systems more pluggable. So you'll be able to more easily add your storage system to the mix, and will allow us to give a lot more support for more storage systems across the board for any CoprHD user or developer. This is a great advancement. We're rewriting that as we speak, and concurrently with that development, Oregon State is contributing a new Scale.io driver that they are developing with our engineers in collaboration with us that will replace the existing Scale.io driver eventually. In the OpenStack integration instance, we have to thank Kurt Bruns from Intel, as well as a few other Intel engineers, including Reddy Chagam, who you'll see also later on in this video talking about software-defined storage. And in each of these cases, it's a demonstration of how much the CoprHD community ecosystem is growing and how much we're getting new contributions that will surface in future CoprHD releases, beginning with CoprHD 2.5, which we're looking to be end of spring to 2016 or early summer 2016. To that end, we are having our our second developer summit in January at Oregon State campus in Corvallis, January 12th through 14th. If you go to coprhd-summit.eventbrite.com, you can register. We'll be posting an agenda very shortly, and as well as some hotel and other logistics information. So if you go to CoprHD Summit, that's coprhd-summit.eventbrite.com, you can find out the information about the summit. The first 2 days will all be about reviewing the submitted feature design proposals, and then the third day will just be a hacks day where we'll actually collaborate with other engineers on different projects. It'll be a fun time. Come by and find out more about CoprHD and how you can contribute. One other thing, we have a technical steering committee which now features Ben Perkins, Bill Elliott, and Tom Watson from EMC, and then Reddy Chagam from Intel, and Shane Huddleston from Oregon State University. They will be the ones reviewing these submitted feature designs. They'll be reviewing those, and they'll be making decisions about what constitutes the next CoprHD release and all other features that go into the roadmap for future releases. This is a great advancement for our community. It shows that we are moving the administration and governance of the community away from EMC into a more independent group of engineers and other interested parties who are going to define what the CoprHD community is. We changed the license from the Mozilla Public License version 2 to the Apache License version 2. We think it's a much more conducive license for cloud users, operators, and developers to more fully participate in the CoprHD community, and for us to more fully participate in other communities. And so we just think it's a better license considering where we are and the cloud architects and administrators that we want to work with. So that's the licensing change, the governance change, the bylaws you can find on the CoprHD wiki. If you go to coprhd.org and go to our wiki, you'll see a whole section on governance and bylaws, and you can read more about it there, including the technical steering committee that we're just announcing. So sit back, relax, enjoy the show, and we've got a lot more news and exciting announcements coming your way. Thanks. So the first person I want to talk to is Reddy. Reddy coming us from Arizona. And Reddy has been working on a lot about, he's been contributing in many ways from an architecture standpoint. He's a storage architect for Intel. And he's going to tell us a little bit about software-defined storage and where Copperhead fits into the software-defined storage pantheon. Reddy, are you on? Can we...
Thanks, John Mark. So let me spend a few minutes going over what do we mean by software-defined storage, and then how Copperhead actually fits into this software-defined storage architecture. So the slide you are actually seeing essentially is a data center view of how software-defined storage can be viewed and deployed. So there are two elements in the software-defined storage. One is obviously the actual storage systems that actually provide the storage services. We see three different types of storage systems deployed in a typical data center, coming from multiple vendors, of course. One is you can take the standard high-volume server and deploy some sort of open source software, like Ceph, as an example. Or you can overlay the standard high-volume servers with proprietary software like Scale.io. Or it could be the traditional, arrays, SAN, NAS, all-flash arrays. Irrespective of the type of storage systems deployed in a data center, you need to be able to manage these resources and service the applications. We see that the software-defined storage controller providing the management plane, for the data center-wide storage resources. Broadly speaking, there are a few elements that the software-defined storage controller brings onto the table. The initial element of software-defined storage controller is visibility of the storage systems, irrespective of types of vendor systems that you have in a data center, irrespective of whether it is a scale-up or scale-out architecture, and able to carve out the storage resources much more optimally based on what applications are looking for. So we see that software-defined storage brings in these two elements: storage systems, scale-out, as well as the management plane via the software-defined storage controller. So there are two sets of APIs that John Mark was talking about in his kickoff. One is the northbound APIs. These are the APIs that orchestration stack and applications use to interact with the software-defined storage controller. And then the southbound APIs, essentially the drivers that interact with the storage systems that brings in all the elements associated with visibility as well as storage resource allocation. So let's take a look at how Copperhead fits into this architecture, which is the next slide. So Copperhead is essentially the open source SDS controller instantiation of what I talked in the previous slide about the SDS architecture. Few key things to remember when it comes to the SDS controller and Copperhead. The initial ingesting the storage resources into Copperhead SDS controller starts off with the discovery phase. And the discovery includes broadly three different types of, infrastructure elements in a data center. One is storage systems that are actually deployed in a data center. The networking element, it could be a fiber channel networking that actually connects your compute and storage. And then the third one is the compute, side of the configuration. So you should be able to discover all those three elements for you to intelligently allocate the storage resources, as well as create a data path that works right during the provisioning phase. So that's what you see in the bottom. So you have the storage backends, whether it is open source or proprietary, scale out or scale up. They actually get composed into a logical construct called virtual storage arrays. Based on certain predefined, the admin defined policies that you can actually group the storage resources. It could be a performance-based storage backends. It could be capacity-based storage backends, or it could be, somewhere in the middle, cost optimized, throughput optimized as well. These are the policies that the data center admin uses to configure and group those storage resources into virtual storage arrays. Copperhead controller brings in the elements associated with the discovery, grouping of those resources using the rich SLO-based constructs and policy-based constructs. And then, of course, the provisioning when the resource requests come through the orchestration stack. So there are two ways of actually using the Copperhead controller. Obviously, you can use the command line and REST APIs as a mechanism to use low-level constructs and do everything, or you can actually use the catalog, based UI that gives you a lot more richer interface, and then you don't have to go through a whole lot of understanding the lower-level REST APIs. The integration element, the way it stands out today from a Copperhead integration perspective, we have the integration with VMware. We have integration with OpenStack, and we are continuously focusing on how to ease the integration into OpenStack by doing OpenStack API-based integration with the OpenStack services. So those are the two elements. But our goal and vision is that the Copperhead integrates not with just one orchestration stack, but it actually integrates with across all orchestration stacks. So if you were to look at the bottom side, it is integrating with a wide variety of storage backends, whether it is scale up or scale out, whether it is traditional arrays or completely open source deployed on standard high volume servers. And then on the orchestration front, we need to be able to integrate across the board, irrespective of the orchestration software that you have deployed in a data center to manage the storage resources or consume storage resources. This includes VMware, Microsoft, OpenStack, and then the cloud native computing framework like Docker and Mesos. So we see that those two elements are the key foundation for our focus in the Copperhead community.
Thank you so much.
Thank you, Reddy. I think we have a very good idea now of what Copperhead is, who's contributing, and all this other good stuff. We look forward to extending that ecosystem, getting more participants, and pushing it even further. So right now, let's I mentioned. So you're seeing you're seeing me. Oh, good. So we mentioned new governance, new licensing. This is a very new development for us. When we first did the Copperhead open source announcement, people were wondering if we were serious about it. And I think this is the best thing we can make about how serious we are. Moving into an open governance model, having the technical steering committee provide the guidance and direction for the roadmap of Copperhead, having other participants externally be on that technical steering committee. So today, we're going to announce that technical steering committee. It consists of Ben Perkins, Bill Elliott, Tom Watson from EMC, and from Intel, we have Reddy Chagam, who you heard just a minute ago, and then we have from Oregon State, we have Shane Huddleston. So this marks a really big departure for us. It's new territory for us, and I can assure you, this is just the first step. We're going forward with a plan for an open governance model, and we're just pushing it to be more open. And I think in the next couple months, I can't make any promises, no forward-looking statements and all that, but I think you can expect this to continue. This is just the beginning. Right now, it's an open governance model. In the future, it could be an open governance model with more formalized structure. Put it that way. So, I think we have Ben Perkins on the line. Ben, are you around?
Are you around?
I am.
Fantastic.
Fantastic. You want to talk about
what you've been doing with Copperhead and the governance model, and what you're doing with the TSC, and how you see that shaping up going forward?
Okay. Well, I think this year has been sort of a process of evolution for Copperhead. In the 2.3 release timeframe, it was largely a technical and legal exercise to get the code ready for release. With the 2.4 release, it's been more about building the entire release in an open source infrastructure, all of the designs, all of the code, everything developed in the open, but still largely by EMC engineers. But at the same time, we've had a community forming up around Copperhead. You've already heard from Reddy. You've heard mention of Shane from Oregon State and all the various other folks that are contributing. And so I think the story going forward is going to be the open source community really beginning to come together and form and start setting the direction and make concrete contributions to the future releases of Copperhead, and that's what we're excited to see. And so I think with regard to the governance model, we spent quite a bit of time setting it out there, getting feedback from all the stakeholders in the community, and now that we've activated it, we'll start to operate under the bylaws that we've published on the website, and so that'll be the new step that we'll be taking going forward. And so we'll, as you mentioned, we'll have technical leadership that's driving the direction of the project.
Great. And part of actually, moving forward is to have new users, and that's why it's very important to us to have new formats to be able to consume Copperhead more easily. We have an OVF that we released with this version. We have a Vagrant version that you can now consume, and it pulls down the latest release code that you can integrate. And so you can, right. So sorry, laptop shenanigans with WebEx. We love WebEx. Did we mention that? So so we need, anyway, my point is to get new contributors, you have to have users and developers, and they kind of go along together. Reddy or Shane, do any of you guys want to add to the conversation around governance, what we're doing with an open model? What does an open model mean to you guys?
This is
Shane, go ahead through that.
Yeah, I think I guess the part that's the most important to me is this is what we view as critical for our participation. This is a big deal for us. Because we believe in the software and the strategy. We think that we need an open source controller. So the fact that it is open and the direction we're taking on the guidance is a huge deal for us. It's something that we quite frankly we're waiting for, and so at this point we're very happy to be helping wherever we can in that process.
What attracted you to the CoprHD community to begin with?
I think the vision of the product and the fact that it was that you guys were going open with it. So obviously, university, we big fan of open source, right? And so for us, it's a way to meet operational challenges. We're, like I said, the vision of the product is something we're very interested in for operational concerns or issues. But the other side of this is we really didn't want to give away kind of what we think of as a control plane for storage to any particular vendor. We kind of wanted that to be an open source product, and so perfect fit. And then we're excited about getting our students into the project as well as contributors.
That's great. So it was very important to you not to have a lock-in to any particular vendor. It was all about having this open community that you knew would not lock in you or anyone else that would be using your storage systems.
Yeah, absolutely. That's a critical. That was for us. That was a critical requirement, and so only game in town. So.
It's an open source guy. So
thank you, Shane, and thank you, Reddy, and
and if we have any other TSC members, they can pipe up and speak if they want. But I think we're going to move along and go to the other end of the world, out in Bangalore, India, where we have a couple of guys dialed in. We're going to tell you all about community activities there and some things that they've been doing. Well, we have a couple of guys, Anil, and we have Malari from Bangalore, India, who are on the phone and should be able to talk through kind of what they've been doing. They had a summit, a developer summit in India. They've done a lot of activities, and they've got a lot of projects that they're kicking off and have kicked off and are going to continue to do. So, Anil, Malari, are you guys out there?
Yeah. Hey, John. Yeah. So in India, what we are doing is we are working with many institutes for building Copperhead communities. We have seen a great interest from academia institutes, and in that context, what we did is in the last month we conducted a pre-summit. Around 90 students attended the summit. The first two summits were mainly in southern India. So that's where the EMC Bangalore office is physically located, and we are also there. And the last one we conducted in northern India, basically in the EMC Delhi office. What we did is basically these were the summit. We have done the recordings, and these have been uploaded in the YouTube under EMC Academics Alliance channel. So anyone can go and take a look at it also. That's one thing we've done it. And mainly for the third summit, since the YouTube recordings were available, we asked the students to go through those recordings, and then the session we restricted only for 2-3 hours. So that's what we have done it for the summit. And there is a lot of interest and a passion for the students, because one thing, it's a win-win model, because they are getting a first-hand experience to work on an enterprise-grade software development with an active mentorship from the industry. So that's it's a win-win model, and the students are very keen to contribute it. So the way, next slide, please. John? Yeah. Sorry, the previous slide. Yeah. So what we have done is, it's okay. The next slide. The way we have done is, typical summit day looks like, for example, what we do is we do a quick overview of the program, and then we do a 1-hour deep dive session on Copper architecture, and then post that we focus on activities like typically a Copperhead developer performs on day-to-day, like deploying Copperhead, installing simulator, and do a demo of basic workflows. What we do in the second half is we walk through them a dev setup, ask them we show them a bug fix and the code review process so that they are aware of it. In the last few hours, we use them IP so that they do play with the Copperhead and get their hands dirty. So that way, we do it as a typical one-day life cycle, how a typical developer does in Copperhead world. Next slide. Yeah. So what we have done is, since we are working with the students, we have given them those 5 assignments, and we tell them that if you want to become a Copperhead contributor ready, you should have done these things. Once they do these 5 activities or assignments, then they are eligible for Copperhead contributor ready, and then we are allocating them a project to work on various activities. We have also created a Copperhead India developer group, basically so that we can provide them a support, and the knowledge repository builds on its own, and the community itself can support it. So that's what has been done. Next slide. Yeah. So these are some of the event pictures where we did this is the first summit on the first day, where we are doing explanation of the architecture, the program, and some of the students who joined EMC Bangalore office. Next slide. Okay, that's it. So,
thank you, Bly. Yeah, that was
the microphone.
That was the
Yeah, you gotta talk.
that was the last slide. I had to cut it short a little bit.
No,
and
don't.
Right now we're getting our next guest ready. We're going to be talking about the Southbound SDK. Again, this is a key feature for Copperhead development going forward. So this is how we're going to.
Are you ready to talk?
This is how we're going to add in new storage systems, new storage plugins. This is how we're going to expand the storage ecosystem so that if you're a Ceph user or a Gluster user or a NetApp or HDS or some other storage user, you'll be able to plug it into the Southbound API and just go. And so it's all about making the storage providers easier to use, easier to consume, and then easier to add to the orchestration framework that you have set up. And so I have with me today, I have Evgeny. And what is your, hi, how are you doing? So what would you like to tell us about? How did we get started on the Southbound SDK?
We were thinking about
Microphone.
simplify way to develop storage drivers for third-party arrays. So currently, if we need to add new storage array to CoprHD. We need to modify many files, add support in many places. So that may be kind of blocker for fast development of storage drivers. So we thought that we will define device-independent, CoprHD-independent SDK, which will have API for discovery, provisioning, and also will have independent object model.
So what can you do right now? Like, where do we stand with the southbound SDK code? What's the status?
Okay, currently we have good progress. On the southbound SDK, we have SDK defined as a draft, and also we in the process of implementing support for SDK in CoprHD. So we can discover storage, discover systems, pools, ports, and also create volumes, delete volumes, consistency group support, snapshotting support.
And how can people check out the code? What's the recommended way to actually get their hands on what you have so far? Where do they go?
The SDK itself is published on the wiki, so it's publicly available. CoprHD support for SDK, it's in the one of the branches which are also publicly available in the Git, in the stash.
So if you go to CoprHD.org, you'll see a link that takes you to the Atlassian Cloud Wiki, which we have. And from there, it'll be one of the projects that are laid out on the left-hand navigation. But once you find there, we have links to the code base that you can download. I think there's a jar file that you can download.
Download jar file with compile jar file and source jar file.
Okay, excellent. And when can we start seeing some of this find its way into the master code branch, into a main CoprHD release?
It will be close to the April release.
Okay,
Yeah.
All right. You heard it from the man himself. Yes,
Yeah,
that will be it.
2.5,
CoprHD 2.5, yes.
Yeah.
Excellent. No, and this is going to be a great thing to add for the CoprHD community. It's going to be a great thing going forward, and that's how we're going to expand. All right. Thank you, Evgeny, for coming by. And I think, let me see who we got next on the line. Excellent. So we're going to segue now into talking about, thank you, Evgeny. We're going to start talking about our OpenStack integration. We have on the line, we have Kurt Bruns from, what? Yeah, Kurt Bruns talking. Kurt Bruns is dialed in. He's going to talk about OpenStack integration and what our plans are there. And I think Kurt is also special because he was the guy who created all the Vagrant stuff. So if you go to CoprHD.org and you go to the download page, if you see a link to using Vagrant to set up CoprHD, he's the guy who did all that. And so kudos to him for making that happen. Kurt, are you on the line?
So they are not using the same WebEx, is that?
Why don't you walk us through? So Kurt, hey, so Kurt, why don't you guys, Kurt, why don't you walk us through the slide that we have up currently, and then that way we can walk through what we're doing with OpenStack and how we're doing integration.
And try to make it 2 minutes. No problem. Yeah, thanks, JM. So this pretty much goes back to what Reddy was talking about earlier in terms of talking to the orchestration stacks with CoprHD. And so in this slide, you can see that this is an integration inside OpenStack where we have Cinder talking to third-party arrays and then CoprHD being used as the control plane in OpenStack for the storage. So it has both support for the Cinder API as well as the Manila API. And then you have a third-party support module that then talks to Cinder or Manila and then talks to backend. And so the CoprHD can be used with its native API, REST, CLI, and the GUI interface that people are used to. It can also be used to manage Cinder backends through the Cinder API. So it'll talk up through the orchestration stack, in this case OpenStack, through that Cinder or the actual CoprHD native API. That's something we're working on, both Intel as well as team at CoprHD team at EMC. If you go to the next slide, there's one example of the API that Intel's been working on, which is supporting QoS specs. So this is the OpenStack V2 block storage API spec. And if you send this GET request via the REST API into CoprHD with the sender API support, you'll have CoprHD actually respond and pull out the QoS specs. And in our case, we're relating QoS specs to virtual pool specs, which is the CoprHD meaning of those. So this code is in a feature branch right now. It's not in the 2.4 release. The plan is to integrate this potentially for the 2.5 release, similar to what Evgeny is doing with the southbound SDK. I think that got John Mark.
Cool.
Cool.
That was actually perfect. Thank you. All right. So, and then we have two more guests we want to show you. One is developing the Scale.io plugin with using the new Southbound SDK that you heard about from Evgeny. And then we've got another special guest coming after that. So right now, why don't we go to Shujin? Are you there?
Okay.
Take us away.
Okay. Okay. So Warren will be the one presenting. Go ahead.
Hi, all. We at OSU, we're actually working on we are actually developing the Scale.io driver implementation using the Southbound SDK. So this actually gives the overview of the high-level architecture what we are actually working on. Here, as you can see from the presentation, the Scale.io driver, which actually, it works at an upper level. It interacts with the driver intermediate level, and at the lower level, it actually interacts with the Scale.io devices directly. So it doesn't actually interact with the CoprHD, and this the kind of advantage is that it's not dependent on the CoprHD infrastructure services for its implementation. The other thing is that it's not bound to the CoprHD persistent data models. So moving on to the next slide. Yeah. This is the approach we are actually following. I would like to explain the different functionalities of the Scale.io driver which we are implementing. The first thing is that the main functionalities of the Scale.io driver is the discovery and the block operation and the provisioning operations. As part of the discovery, we are actually working on discovering the storage systems, the storage pools, and the storage ports. From the provisioning perspective, we are actually working on creating basic operations such as create and delete volumes and snapshots and clones, etc. As you can see from the presentation, during discovery, all the connection informations and the credentials would be stored in the registry for further use. The same things would be used by the provisioning operations. They fetch all this connection parameters from the registry and do all the provisioning operations. Similarly, from a general approach, we are using the REST client API to implement the discovery and provisioning operations. And using the REST client handle, we access all this connection parameters from the registry, and we create and handle the Scale.io device. So I think that's the pretty much fun stuff we are working at OSU.
That's great, Varun. Thank you so much for telling us about that. Again, so this is they're developing this concurrently with the Southbound SDK. It's kind of being used as a test system to guide us as we do the Southbound SDK itself. So they're in touch with each other all the time, working together. It's just another example of how having an open source approach makes for a better, innovative way forward. And now, I think we have a very special guest where we're going to have Mr. Larson. And if you were paying attention to the press release that EMC put out yesterday, you noticed that the headline was about something called RackHD. And RackHD is a wonderful new project that is being developed by a team, some of whom came from a startup that we acquired earlier this year. And they put out this thing called OnRack, and then later on they decided, well, you know what? Open source seems to work so well, why don't we open source that? And it's all about sort of bare metal telemetry, bare metal orchestration. It's cool. So people are laughing. Anyway, never mind. Bare metal orchestration, that is a hilarious thing. So why don't I take it away, Tim? Tell us about it.
Yeah, thanks, John Mark. It's great to be here this week. It's been an exciting week. As you were stating, this is really kind of the big second open source offering that we've done as a company, and really started out 2 years ago, focused in on solving this problem around how to deal with bare metal management and orchestration. And so it worked out quite well as we were talking through the last couple of weeks as you guys are getting ready to do your announcement, and we were getting ready to go forward with our open source as well, and our project just seemed so good to be able to bring these two projects together in a synergistic way, and both having a presence on EMC code and being able to continue to further what we're doing for EMC around open source has been a very exciting thing to take on this week. And
Great.
So really excited to build the community.
So what is RackHD exactly? Can you tell us in like
Yeah.
30 seconds, what is RackHD?
Yeah, absolutely. So the intent was to create a way to deal with varied hardware platforms, but make them look homogeneous to a northbound stack. And so it was really this ability to dynamically discover different platforms from different vendors, be able to bring it into what we call a dynamic catalog, and then present that northbound in order to create a real standard way in order to interact with the environment. And we drive down this path of being able to create a substrata that makes composable infrastructure very manageable, especially at scale.
What's composable infrastructure?
Yeah, so it really gets into this idea that having a bare metal infrastructure that I can change what it does on a day-to-day basis through different workflows and executions of tasks we do on the platform. So a simple example, I take a particular platform, we'll take a Supermicro box and a Supermicro server, and I want to deploy a bare metal Linux onto that platform, but tomorrow I want to erase that off and put on a bare metal Windows deployment. The RackHD technology gives you this real easy API command and control over these platforms to be able to do these personality changes inside of the environment, but to do it through a very easily usable API infrastructure. And so suddenly you get very good command and control over all these different hardware platforms, something that we deal with a lot as we've gone forward inside of our infrastructure and our appliances. And so it's really a more manageable way to deal with your infrastructure at scale.
Great. And so what's the next step? What are you guys going to do next? Now you've had your bigger release, your big announcement. What's the next big thing for you guys?
Yeah, so I think so much of what we do initially is really around validation of our what we thinking, dead on with how to solve these problems, how to drive some synergy within the community, similar to what you guys have been doing, where you're starting to get engagement from your base and starting to drive a broader community presence. For us, we're very much focused on this as we go forward. Certainly the launch is a big part of that this week, is to get awareness out there. Being up in EMC code will help with that as well, and start getting more engagement into how the technology is going to continue to evolve. We'll be doing a lot more of the evolution within the technology. The biggest thing probably is expanding our workflows in order to manage many different SKUs and many different vendors. Currently our current what's published is really focused in on a couple platforms, which is specifically Quanta as well as some of the other EMC white box catalog platforms, but very interested in having the community help drive a much bigger adoption rate and a much bigger usage of the different platforms that we support.
Are you going to be integrating with CoprHD, for example? We have a developer summit coming up in January at Oregon State, which I'll throw up a slide here in a minute, give you the details on that. But
so that's another big piece of what we've been talking about over the last couple of weeks is as we think about how bare metal management and orchestration works, and really being the control plane for the substrata from a bare metal perspective. What CoprHD also provides, of course, as a control plane on the data pane side, is really gives us the ability to have synergistic positioning between the two different packages. So we're very interested in looking at synergies between them. We have a project already going on internally where we're looking at how to have these two different packages synergistically provide an improved infrastructure, and that'll be more to come, especially as we start driving these two communities collectively.
Fantastic. Hey, thank you so much for coming by, Tim.
Thank you.
All right. Excellent. So we've got one final thing to tell you about. We're going to tell you about what we've got coming up next. The next big thing we're doing is the Developer Summit, because we just had a big release, 2.4. So now we're getting ready for the 2.5 release cycle, which means that we're going to be accepting submissions of blueprints that we're going to talk about, and the TSC is going to look at and review and decide, oh, no audio. Oh, hey, imagine that. Yes, I love WebEx. WebEx is awesome. So yes, we're going to be looking at how we're going to approach the next release cycle. So all the stuff that you're seeing now, the new projects we've announced, we're going to talk about how we're going to weave that into the release cycle process, and at what point it'll arrive in the master branch and in the future releases. So get ready for 2.5. That's coming up. We're trying to hit like a 6 or 7 month release cycle. We'll see if we can actually do that, but it's a good aspiration. And so getting ready for that, we're going to decide all this stuff at the next developer summit. It's coming up January 12th to 14th at Oregon State. It's going to be at in Corvallis, Oregon. And that's where we're going to have a 3-day extravaganza, 2 days of going through blueprints and stuff that's been submitted, and how we're going to decide what's goes in the next release. And then on the last day, it'll be just a hack day. A bunch of engineers and developers getting together and just working on cool stuff. And so that's the next big thing. Sign up here, show up, get ready to work, and hope to see you there. And Ura, parting shots, man.
Definitely, I would recommend everybody go check out the new website, CoprHD.org. Same old website, new design. And in there, you can find the links to our weekly community meetings, which are every Wednesday at 11 a.m. Eastern Time. It's a little early for the Pacific folks, so, sorry, wake up, I guess. Most of these guys are early birds. Also, go to our Google group, CoprHD. You just search for it. It will be right there. And, just come by, say hi, and be part of the community. We're looking for everything and everyone. You can help us as a user. You can help us test. You can help us develop. If you have a great idea for a new feature, we want to know. And we're making the call out there to all the other companies. Come and play with us. I mean, we all keep talking about interoperability.
And if I didn't mention it before, this guy really is the guy who makes the CoprHD community go. If you see that website at CoprHD.org, that's all his doing. You see
Not my fault.
the new branding that went into this release of CoprHD to make it look like CoprHD. That's all his stuff. He's the guy who just puts the community on his back and soldiers forward. So many thanks to Ura for making that happen. So
no need. Anyway, all you other companies out there, everybody, we want to play with you. Come over, please. We can't really interoperate between each other if we don't actually sit down and talk about things and make it work.
And besides, if you join, you can actually join us here at one of these fancy events where we'll put you on camera and let you get your time. So there you go. All right, I think that's...
the next one of these will be in January 14th.
There you go. He called it, January 14th.
We'll duct tape it together. We'll do something. There will be another one of these.
We apologize for the technical difficulties at the beginning, but once we record it and throw it up on YouTube, you won't know this ever happened. So.
Hopefully it'll be awesome.
All right. Thanks, everybody. And until next time, the next CoprHD Community Show. Yeah? All right. Thanks.
Thanks.